Maybe meanwhile I am writing something so that I can utilize time. Okay. Meanwhile, I think BTech students are about to join. Maybe I can write down something so that I can save the time. Yes. I think now we can start. So, okay. Good morning, all of you. So, we will further discuss about our next method to find out the iteration bound. So, yesterday we have just seen two method of the iteration bound where we can find the iteration bound through loop bound as well as we can find the iteration bound through LPM method, longest path matrix. I believe that you have tried it out that example where you have created all four matrix and then from that matrix the diagonal element that you need to take care along with the which matrix you are talking about, so that you need to divide with that value. Okay, and with that whatever the maximum value is there, that you need to consider as your iteration bound. Now another method in a similar line that we can think about is a minimum cycle mean method. Okay, minimum cycle mean method is also one kind of algorithmic method like your longest path matrix method, where there are some finite steps that you need to follow and through which you can find out the iteration bound of any particular DSP system. Now we will see the same example whatever we have seen for a previous two method. that this is the graph which we have used it for our loop bound method as well as for our iteration bound method. Now, when we talk about the third method, for which also we are talking or we are taking the same example. Okay. Now, this method is also depend on a number of delay element in your original graph. Okay, like LPM method is also the complexity of LPM as well as the MCM method depend upon the number of delay element inside your graph. Okay, so that means the complexity has to deal with the number of delay element, not the number of node. Okay, so that you need to just ensure that when you talk about the algorithmic method. Now, it defines upon minimum cycle mean. Okay, this method. Why it is being defined that? Because ultimately we need to find out the cycle mean. Cycle mean, that means we need to consider a cycle among the different nodes, and for that we need to find out the delay element, and according to that we need to find out the minimum cycle mean. Okay, so how it is being done or what steps you need to follow, that we will discuss. Now, consider that this is my original graph. Okay, original graph nodes and your delay elements are already being defined. Now, from this particular graph, you need to construct this graph. This I am defining as my GD graph. Okay, so first step that you need to follow for a minimum cycle mean method is you need to construct your GD graph. Okay, how you can construct a GD graph from your DFG? This is my original DFG. From this, I need to construct this graph. Now, for this particular graph, which we are interested to construct, for that, the node is the number of node of a GD graph is equal to number of delay element in your original DFG. As I said that this MCM method is also deal with the number of delay element. The complexity is all depend upon the number of delay element. So here in a GD graph, the node which I am going to represent over here, that is nothing but number of delay element. So here the number of delay element I have D1, D2, D3, D4. So that's why 1, 2, 3, 4. So this one is you need to consider corresponding to D1. This is corresponding to D2. This is for corresponding to D3, and this is for corresponding to D4. So you have total 4 nodes in your GD graph. Why 4 nodes? Because you have a 4 delay element in your original graph. Okay. So nodes are being identified. Now node has to be connected through some edges, and those edges should have some weight. Okay. So we have seen that in a graph, basically you have a node. Nodes are being connected through edges, and edges having a weight. Now, ultimately, edges suggest that there is a way through which I can reach from this particular delay element to this particular delay element. If there is a way, or in another sense, if there is some path do exist, then I need to define by edge. So that means if I consider D1, so D1 to D2, D1 to D2, there is some path. This part is there. So that's why there is one edges. Now 1, 2, 3, 1, 2, 3, I cannot reach. So there is no actually edge which goes from 1 to 3. You can connect 3 to 1. That's why there is an edge. Okay. So from which node? So that means D through to D1, there is a way I can reach. Similarly, if you observe 4 to 1, I can go. So that is 4 to 1. 1 to 2, I can go. Again 2 to 1, I can go. So that is this part. So I will start from this point and I will end up at this point. So there is a 2 to 1. There is a edge. Okay. So whenever there is a path exists from one delay element to another delay element, then in this particular GD graph, that has to be represented by edge. Okay. Absence of edge suggests that there is no path to reach from this node to this node. Is it clear? Okay. Now, once we identify a edge, then we need to think about the weight which I can associate with this particular edge. So now, weight is nothing but the execution delay of a node which comes through your path. Weight of a edge is nothing but, what is the edge? Edge is nothing but a path which suggests that I can reach from this node to destination node. If I travel from source node to destination node, if in between any functional unit which is being represented by a node in your original graph, that node is having some sort of delay. So that delay I need to calculate and I need to sum it. And that summation of the delay I will define as the edge of that particular or weight of that particular edge. Okay. So if I travel from D1 to D2, there is a edge. So I have defined that edge. But there is no delay because there is no node in between. So that's why here it is being defined as a 0. So path is exists, but there is no weight for it. Similarly, D2. Now if I talk about 2, then 2 to 1, I can go to this particular part as I defined it. So there are 3 nodes, 4, 2, 1, and the delay which is being associated with this node is 2 plus 1 plus 1. So total 4. The weight is from. So there is a weight through which I can go from 2 to 1, and the weight of that particular edge is 4. Because when I travel from D2 to D1, 3 nodes comes, and if I take a execution delay or summation of the execution delay of all 3 nodes, then which comes out to be 4. Now similarly, this is applicable to all the nodes. So if I talk about, let's say 2, then 2 to 3. So 2 to 3 I can reach out, but there is no in between node. So that's why 2 to 3, but delay is 0. 3 to 4, again 3 to 4, you can go, but there is a delay or weight which is being associated is 0. Now when I go from 4 to 1, so that means this way 4 to 1 I can reach. So there is a way 4 to 1, there is a edge is being identified. Now for that 2 plus 1 plus 1 plus 1, so that is 5. Similarly 3 to 1, 3 to 1 is possible this way. So that is 2, 1, 1, 1. So that is 5. This is 5. So this way you can define a relation among the delay element by providing the edges, and the weight of those edges is for that particular part whatever the execution delay of the node. So with this way you need to construct your GD graph. Okay, now another thing is, it may happen that sometimes in a graph you will observe that there are multiple ways through which I can reach Di to Dj. If from delay element Di to Dj there are multiple paths, then you need to consider the longest path. So it may happen that from particular delay element to another delay element, I can go through a multiple path, like a simple case like this. If there is some graph, now if I consider this is D1, this is D2. So now this D2 to D1, I can go through this as well as I can go through this. But the longest part will be this, where I have a 1 plus 1 plus 1. So D1 to D2, I can reach it with 3, as well as D1 to D2, I can reach it with 2. So I will consider this part and I will assign a weight for D1 to D2 relation as a 3. So you need to consider the longest path. As we need to consider the longest path, then most probably you will find out the only unique value. There can be a two longest path, but weight will be the same. Then weight will be only once. Okay. So don't be confused if there are multiple paths to reach from one particular delay element to another delay element. So at that time only also you need to find out only a longest delay. Okay. So this is the first step. That means from my original DFG, I need to construct GD. Okay. Once you have constructed the GD, then actually you need to construct GD bar from that. Okay. GD bar is nothing but see here the name GD. Why GD? Because it is a graph of delay. This D stands for delay and G stands for graph. So graph of delay, because here the node is nothing but my delay element. Now here it is GD bar. So GD bar is nothing but the complement of my GD. So if you observe that the graph GD bar is same. Okay, but GD graph, whatever the weight that you have taken a weight value is just opposite. So here and here, if you observe that there are nothing differences. Sorry, I forgot some value. So that is 0, 0. But if you observe here 2 to 1, 4. Here it is -4. Here 4 to 1 -5. 3 to 1 -5. So whatever the original value, that is opposite the value. So usually you will find out that in GD, always you have a weight value positive or 0, while in GD bar you have a weight value 0 and negative. Now why we are interested in GD bar? Because this algorithm is actually talk about the minimum. When I consider a longest path, then it always give you the maximum value. So if I take a opposite value, then automatically it will be converted into the minimum. I hope you realize it. Because if I consider this 5, then 5 is the maximum, but -5 over here is a minimum value. Okay, so that's why, and actually to find out the longest part is easier. Okay, there may be a case that you can find out directly the minimum distance from a means a particular graph. Okay, but somehow the longest path algorithm we are using. So first of all we are finding the longest path and then we are taking a opposite of that value. So that's why it becomes a minimum path, or you can consider the least path. Okay, so that's why GD bar is we are considering, and this graph now we need to use it for our analysis. Okay, now yes.
So the longest path has to be delay-free.
Actually, if we consider that I am okay, let me connect with the MTech. MTech, the question which is being asked by one of the BTech students is longest path has to be delay free. Okay. Now, if you observe that here you are actually finding a path from one delay element to another delay element. So there would be delay free. Because if you consider that delay element, then that delay element is nothing but the node. Let's consider that here there is a node D3. So in this particular graph, there is a connection from D2 to D3 and then D3 to D1. So D2 will be one node, D3 will be one node, and D1 will be another one node. So if I want to go for a D1 to D2 to D1, then ultimately it is through D3 only. So D2 to D1, whatever the delay that is being there, that I need to consider, and as well as D3 to D1. So ultimately you consider that has to be delay free, because when you consider a delay, then that is the node. So that means over there you need to stop. I hope I have given you the answer. Okay. So now the GD bar is a graph which we are interested. Now you need to construct or there are some mathematical model over here also. Okay, now here you need to construct f of m matrices, or you can consider f of m vector, and this m is again 0 1. I think it should start from 0. No, it is again from 1. Okay, it starts from 0 and it go up to d. So you need to construct fm vector where m is 0 1 2 d. So that means here I have a 4 d element. So that means f of 0, f of 1, f of 2, f of 3 and f of 4. I need to calculate. Okay, now f of 0 is my initial vector, and that I need to assume. F of 0. So as I said that I need to actually go for a f of 0, f of 3 and f of 4. So f1, f2, f3, f4 you can calculate, but for that f of 0 you need to take any assumption. Okay, now for that I am considering a one particular vector. So that vector has to be a column vector, and that is of the size of 1 cross d. So size again here depend upon d. In LPM we are constructing a matrix which is of d cross d. Here the matrix that we need to construct, it is of 1 cross d, that is a column vector. Now initially I am assuming all the elements at a distance infinite, and first element as a 0. So that it is a 1 cross d, that means it is 1 cross 4 column vector. So 4 elements are there, but out of 4 elements I am assuming first one as a 0 and remaining are as a infinite. Okay, now this is a scenario always when you find out a minimum distance. Okay, maybe if you have gone through a CAD algorithm, then also you have realized that whenever I am finding a minimum distance in a graph from a particular source node, then I am considering that initially all the remaining nodes are at infinite distance. Yes, this is actually the theorem that we used to apply for any minimum path algorithm. Okay, so whenever I want to find out the minimum distance from one particular node to another particular node, then initially I will assume that they are at an infinite distance. Now through algorithm I need to find out, as I am talking about minimum, then that infinite value has to be come down to close to 0. So ideally I am considering that they are infinite distance apart, but now as I am interested in a minimum distance, then I need to find out the closest value which is towards 0. Okay, now for this particular vector I need to assume one as a 0 and remaining as a infinity. Now infinity, as I said, that just to ensure that they are at infinite distance, and then from that I can find out the finite value, but one has to be 0. Okay, because if all are at infinite, because this f of 1, f of 2, f of 3 and f of 4 are being calculated from f of 0, and for that the equation is that I think somebody else mobile is running. F of mj is equal to minimum of I belongs to I, where I is not equal to j, f of m minus 1 I plus w bar ij. So this J could be 1, 2, 3, 4. Okay, because sorry, this J is a particular index. I'm talking about this M. Okay, this M is 1, 2, 3, 4. But for that M is equal to 0, we have already taken some assumption. Now, if I need to find out any other value from this, then over there for f of m minus 1, I have to use. Now for that, if you observe that, then you need to use for fm minus 1. Okay, so that means for f of 1, I need to find out, or I need to consider f of 0. If f of 0 is all infinite, then f of 1 would be also comes at the infinite. So I cannot solve the problem. Okay, just to ensure that I will get some finite value, I need to take one element as 0. Now usually in a book they are preferring the first element as 0, but now it is not necessary. But out of 4, any one you need to take 0. Maybe you can take last one as a 0 and first 3 as an infinite. Maybe somebody want to take the second as a 0, first, third and fourth as an infinite. It will work. As far as 3 elements are infinite and only one element is 0, your initial vector is valid and you will get the same answer at the end. There is no difference. Okay. So just to ensure that we would be able to calculate subsequent f of value, f of m value, we need to choose f of 0 where one element has to be 0 and remaining elements I am considering the ideal case that for a minimum path algorithm all are at a infinite distance. Okay. Now I will calculate this different f now. Okay. Now let's consider I am interested in f of 1. So for a f of 1, again there are 4 different elements. So that means for f of 1, I need to find out first, second, third, fourth. So how you can find it out? So let's find out f of 1, 1. So let's write it down, f of 1, 1. So j I am putting as a 1. Okay. So f of 1, 1 is equal to minimum of I belongs to I. Okay. With the equation is f of m minus 1. So that means I need to use f of 0 I. Now I here I should not be equal to j. Okay. So that means I cannot take now I equal to 1. I need to take I equal to 2, 3, 4. So f of 0, 2 plus w bar I is 2, j is 1. F of 0, 3 plus w bar 3, 2, 1. F of 0, 4 plus w bar 4, 1. Okay, so I consider j. So j can be anything, but it cannot be equal to I. So that's why I have considered over here as I consider j is equal to 1 over here. So I equal to 1 is not possible. So it is I equal to 2. I have put I equal to 3 and I equal to 4. And with that I have write down this equation. Now f of 0, 2. So f of 0, 1 is this. This is f of 0, 1. This is f of 0, 2. This is f of 0, 3. And this is f of 0, 4. So 2, 3, 4 all are infinite. F of 0, 2 is infinite, f of 0, 3 is infinite, f of 0, 4 is infinite. So ultimately f of 1, 1 I will get as an infinite only. Okay. So first value is infinite. Now consider f of 2. So I am just putting 2 over here. So f of 1, 2. So f of 0, 1. Here it should be again so here f of 1 w bar 1 to 1, f of 0 3, because 2 cannot be taken because j is equal to 2 over here. Okay, so it is 3 to 1, and f of 0 4, it is 4 to 1. So f of 0 1 is 0, this one is 0, this one is 0, plus w bar 1 1. I comma j. Sorry, it should be j. Yes, it should be 1 2. Thank you. Here it should be 2 always, because I am talking about now j is equal to 2, 3 2 4 2. Okay, so f of 0 1 is 0 plus w bar 1 2. W bar 1 2, that means GD bar. When I say bar means that means the value it is in GD bar. So it is 1 to 2, value is 0. So 0 plus 0. This is also 0. So that means first value is 0. This f of 0 3 and f of 0 4 infinite. So this actually considered as an infinite only. So here the second element is 0. Okay. Now put f1 3 where j is equal to 3. So ultimately j is equal to 3. Again you need to solve this. I believe you can do it. Just try it out. Yes, MTech, please try it out. So you need to find out now f of 1 3, which is this element, which is f of 1 3, and this is f of 1 4, and give me the remaining two values. If you are not getting, then let me know. Okay, I want answer from MTech. What is f1 3 and what is f1 4? So once you find out f of then same equation you need to use, but here the only thing is here m minus 1. Okay, so while I am calculating f of 2, I require f of 1. When I am calculating f of 3, I require f of 2. And while I am calculating f of 4, I require f of 3. So same equation is there, and you need to find out the all four matrices, or you can consider it is a column vector. Yes, MTech, what is f1 3 and f1 4? Hello?
Yes, sir. Yes, sir.
Okay, f1 3. Okay, at least I confirm that you are connected. What is f1 3? What is this value? I think that it should be easy. You need to put 3 over there.
So 1 to 3 weight से ये ना मतलब वो exist नहीं कर रहा है.
अगर weight exist नहीं कर रहा है तो वो infinite distance पे. If there is no edge, then in a graph it suggests that they are at infinite. Okay, the weight is infinite. So always there is no h, then you need to consider the weight is infinite. So put that value as a infinite. Don't worry. Now let me know. So it is also infinite.
इन्फिनिटी आ रहा है सर शायद.
ओके ये इनफाइनाइट आएगा, ये इनफाइनाइट आएगा. सो दिस इज माय F1 मैट्रिक्स. इनफाइनाइट, जीरो, इनफाइनाइट. ओके अभी हम जीरो और इनफाइनाइट में ही खेल रहे हैं, लेकिन F2 कैलकुलेट करो अभी. Calculate F2. Okay, so if there is no edge, the weight which is being associated with that is infinite. So let me know what is the F21, that is the first element over here. Very good. It is -4. So first value has to be -4. Now talk about remaining. Okay, complete now remaining. Okay, MTech, let me know what is the remaining element of the F2. This value, and this value. So there has to be 1 cross 4 matrix. All are 1 cross 4 matrix. Yes, MTech, what is the value over here remaining element? So second matrix f of 2 would be -4, infinity, infinity, infinity. If anyone has a doubt, let me know. I can explain. Otherwise, I am considering that you are getting the same answer. नहीं.
सर F2 का थर्ड एलिमेंट एक बार देख लीजिए.
ओके गुड, वो जीरो ही है, मैंने गलत लिखा है.
यस सर इट इज 0.
It should be 0. Good. Okay, now find out for f of 3, same way. So this is actually infinity, infinity, infinity. -4, infinity, 0, infinity. Okay. Now f of 3. f of 3 first value infinity. चलो भाई इंफिनिटी लिखता हूं, इंफिनिटी आ रहा है. देखो, आई एम जस्ट राइटिंग वॉट एवर यू आर सेइंग and all has to be agree if it is correct. So now somebody has changed the answer, so it's not coming infinity. Yes, MTech, what is the value? इतना क्या डिफिकल्ट है? इतना क्या डिफिकल्ट है? Should I solve? I am interested in f of 3 of 1, which is minimum of f of, so this is nothing but m minus 1. So this is f of 2. I cannot be equal to j, so that means it has to be 2 plus w bar 2 1 f of 2 3 plus w bar 3 1 f of 2 4 plus w bar 3 1, sorry 4 1. So f of 2 2, this is infinite, this is infinite, तो ये दोनों तो वैसे ही चलेंगे. f of 2 3 is 0 plus w3 bar 1, w3 bar 1 means 3 to 1 minus 5, goes 3 to 1, 3 to 1 minus 5, so 0 minus 5. So here first element is minus 5, क्योंकि ये दोनों तो इनफाइनाइट है, तो इनफाइनाइट में प्लस करने का कोई फायदा नहीं, इनफाइनाइट का इनफाइनाइट ही रहेगा. And as we are talking about minimum value, so if any finite value comes, then definitely it would be the minimum one. So now find out f of 3 2 similar way. F of 2 1 could be possible, w bar 1 2 2, f of 2 3 plus w bar 3 2 2, f of 2 4 plus w bar 4 2 2. Okay, so f of 2 1 is some finite value, 3 is 0, 4 will be vanished, this will be vanished. F of 2 1, that is minus 4 plus w bar 1 2, w bar 1 2, it is 0. Okay, f of 2 3, it is 0 plus w bar 3 2, 3 2 2, it is 3 to 2, so that is infinite. So that is minus 4. I believe that this value is minus 4. So I believe f of 3 remaining 2 element and whole f of 4 you can construct now. Just complete it. Now I am interested to calculate T infinity. That is your iteration bound. Iteration bound is being defined as T infinity. Minus of minimum I belongs to 1 to D. Maximum of M belongs to 0, 1 up to D minus 1. F of D I minus F of M I D minus M. So T infinity is minus of minimum I belongs to 1 to D, maximum M belongs to 0, 1 to D minus 1, F of D I minus F of M I D minus M. Now here afterwards you need to actually construct one table. Okay. For that you need to consider I is equal to, see, I here it goes from 1 to D. So that is 1, I is equal to 1, I is equal to 2, I is equal to 3, I is equal to 4. And D goes, M goes from 0 to D minus 1. So that is M is equal to 0, M is equal to 1, M is equal to 2, and M is equal to 3. So when I point this particular point, at that time I is equal to 0, I is equal to 1, M is equal to 0. So put that value. T infinity F of D. F of D means F of 4. I is equal to 1 and M is equal to 0. So F of 0, 1 divided by 4 minus 0. So F of 4, अभी ये एलिमेंट आपको बोलना पड़ेगा. बाकी के एलिमेंट क्या है? What is your F of 3? Minus 5, minus 4, infinite 0. What is F of 4? Very good. Minus 8, minus 5, minus 4, and infinity. So you require all these vector. Now F of 4, 1. F of 4, 1 is minus 8. F of 0, 1. F of 0, 1 is infinite. Divided by minus 4 minus 0. So with this, if I find it out, the value, it is 2. But here out of all this, there is a negative of minus. So this will becomes a minus 2. So here the first value is minus 2. So you need to put I equal to 1, M equal to 0 in this equation. And whatever you are getting in front of this is a minus. So with this it's coming out 2, but because of this negative, it becomes minus 2. Now just try to solve for a different value. I is equal to 1, M equal to 1. And with that, try to solve the different value. I am just writing final answer. ये जो पार्ट है ये इसका मैक्सिमम फाइंड करेगा. So maximum of this you need to find out. So maximum here it is minus 2. Maximum here it is -1. Maximum here it is a -2 and maximum over here is infinite. ये जो सारी वैल्यू है उसमें से मैक्सिमम फाइंड आउट करना और इन सब का मिनिमम, ये जो सारी मैक्सिमम है उसका मिनिमम, तो इसका मिनिमम होगा -2 और इसके आगे माइनस है, सो माइनस ऑफ t infinity इज minus of minimum of -2, so which is +2. So this is t infinity. Now if you observe that we have solved the same example with this MCM method, longest path matrix method and your first loop bound method, you are end up with the same answer. Now there are so many equations like this. Okay, so don't worry, in an exam I will help you for that. Okay, usually in your VLSI SP exam, I believe that it is offline exam now because you are here and MTech students supposed to come over here. So I will allow one page to you where you can write down anything. Now if you feel that that equation is somewhat complex, then you can write down this. So A4 page is allowed to you, front side and back side, for your midterm as well as your end term. So if you feel that this equation is difficult to remember, then you can write it down that on A4 page. Okay, so that I will allow because this is somewhat I also consider that not that much of easy. Okay, maybe if you do a practice then you can remember, there is no problem, but still I don't want that because of the wrong equation you end up with the wrong answer. So that is allowed. So for your exam, A4 page is allowed, written one page is allowed, so that you can take care. Okay. Yes, MTech students, any doubt whatever is being covered today?
No, sir. No, sir.
Okay, so I hope that it is for all because I have heard from one only MTech. Okay, so with this we are ending up our iteration bound chapter, which is a chapter 2. Okay, so and probably with this I believe that our online session is also end for a VLSI SPA. I believe that the MTech student would be joining from next to next week for a offline class. Okay, because they have to report next week. So I think from 1st March onwards, we will have a offline class only for VLSI SPA. Okay. So I will announce that for probably for an offline class, maybe we can skip this classroom also because here if remaining 50 students will come because I believe that MTech students are around 40 up. Okay. So if they come over here, then probably it won't be possible. So I will announce that maybe at that time we can go back to our original class LT14. Okay. So with this, I am announcing that next week there is no class from my side for VLSI SPA. Just to ensure that both are on the same page. Now, whatever the part means, whatever the classes that is not going to happen in the next week, that anyhow we can do it from next to next week. Okay, I will cover that because once means they are also on offline, then we can manage maybe after 5 also, there is no problem. ठीक है, उसके बाद कर लेंगे, कोई दिक्कत नहीं. अभी क्या है कि ऑनलाइन क्लास है ना, तो ऑनलाइन क्लास में देयर इज अ रिस्ट्रिक्शन 3 to 4 आवर्स. ऑफलाइन क्लास में मेरे ख्याल से आप 3 घंटे से ज्यादा तो पढ़ ही सकते हो. So that again we need to rely on timetable because I believe that now there will be some changes. There could be a changes in a timetable also. So we need to wait for that. So I will just let you know in next week regarding that. Okay, but that is confirmed that now we are going for a offline. But just to ensure that I can record my lecture, I will come up with the laptop and I will open up this kind of setup. No issue. So I can record my lecture. Okay. So